Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, identifying solutions to a system of linear equations. So reminder, a system is when we have a group of equations in this case, but it could be inequalities or quadratic equations or whatever the case may be, where the variables have the same value. So we have more than one thing going on and we're trying to figure out where they, if you look at a graph, where their intersection points are, which would be the solutions, or where the x and y have the same coordinates, which is what we're looking at now to find the solutions. So what I want to do is for each of these, I have 4, so go ahead and divide this into 4 over here. I'm going to plug the x and y in for up to both. If it doesn't work for the first one, I don't need to check the second one, but I'm going to plug it in for both x and y separately for each equation. If it's true statements, what I'm left with for both of them, then it will be a solution. If either one or both of them doesn't work, then it will not be a solution. So looking here, we have y equals negative 4x plus 3. Okay, and I'm going to replace that with x as 1 and y as 5. So 5 equals negative 4 times 1 plus 3. 5 equals negative 4 plus 3. 5 equals negative 1. That already doesn't work, so I don't even have to check the second one, so that's going to be a no for that point. All right, same thing over here, so I'm not going to rewrite this, but negative 7 equals negative 4 times 0 plus 3. Looking at this, negative 7 equals 0 plus 3, negative 7 equals 3, so that once again does not work. That's a no for that one. Moving right along, these are actually working out nicely because the first one I'm trying is the one that's not working. Sometimes it works for the first one and not for the second, which take a little bit longer to check. So let's see what goes on here. We have 11 equals negative 4 times negative 2 plus 3. 11 equals 8 plus 3, so 11 equals 11, which is true. So now I need to try my second equation to see if it works for that one as well. So I have 12 times negative 2 plus 3 times 11 equals 9. So negative 24 plus 33 equals 9. And that does appear to give me 9 equals 9. Which both work, so that is a yes because I got 2 check marks. It works for both of them. And let's try this last one. And something important to note here, actually. Just because we found a solution doesn't mean it's the only solution, depending on the type of system. Now, after you play around with linear systems a little more, you might realize that this last step is not entirely necessary. But that's fine. We're not going to get to that point yet. So, and we may have one of our special cases. So let's see if we go ahead and through here. So here, negative 9 equals negative 4 times 3 plus 3. Negative 9 equals negative 12 plus 3. Negative 9 equals negative 9, so that does seem to work. And then for our last one, 12 times 3 plus 3 times negative 9 equals 9. 36 plus negative 27 equals 9, which also does actually seem to work. So that means that we have 2 solutions now. So this does mean that we have one of our special cases that I mentioned a second ago. So as you play around with this, you'll find out that either you're going to end up with 1 solution, 0 solutions, or infinitely many solutions. So the fact that we have multiple here means that we're going to actually end up with not just 2 solutions, but infinitely many solutions. We'll explore that a little bit more later.